All right, today guys in section 6.3 we're going to talk about square root functions and inequalities. We're going to graph them here in a second. But before we do all that, okay, let's just kind of talk about these square root functions real quick. Okay, well, what makes something a square root function, okay, is going to be our first definition that we take care of here. All right, well, what makes something a square root function is simply, okay, if a function contains the square root of a variable. Okay, so for example, all right, you got something like that. Okay, like something like the square root of x, you have a square root function. Okay, not like the square root of 4. Okay, that's the square root of an integer. Okay, it's only a square root function if it's the square root of a variable. Okay, now square root functions are kind of a type of radical function. Okay, and a radical function is any function with a radical sign. Okay, so we often mistake it and just call it a square root sign, but it is truly what we call a radical sign. Okay, so radical functions are square roots. Okay, and if you look over here to the left, square roots, cubed roots, fourth roots, fifth, yeah, that's a 5. Let me try that again. Okay, fifth roots. Okay, on and on and on down the line. Okay, those are what we call radical functions. They all have that radical symbol. Okay, now here we have a graph of what the parent function, the square root of x, looks like. Okay, it's that blue line, that arrow that has kind of an origin at 0, 0. Okay, it has a dot at 0, 0, and then curves up towards the right. Okay, now we'll move this graph a little bit and we'll talk about how it moves and why it moves and which way it moves here in a second. All right, but before we do all that, okay, we need to understand and talk about the domain and the range. Okay, the domain here, all right, for this particular graph is x is greater than or equal to 0. If you look at the graph, that's true. All right, here is your smallest domain value, because remember, domain are your x values. And then every x value that's involved in this graph, okay, they all go to the right. All right, so they all are bigger than 0. So that's why our domain is x is greater than or equal to 0. Okay, our range, okay, f of x is greater than or equal to 0 right here. All right, well, that's another way to say all our y values are greater than or equal to 0. And if you look at the graph, that's true. Our smallest y value is 0 right here because every other y value involved in the graph, okay, is up here somewhere, and they're all bigger than 0. Now, those domains and ranges are going to change, okay, when we start to transform our square root functions. And if you look right here now in the middle of your page, right, you have this right here, okay, with these a's and these h's and these k's. All right, this is what we call the transform square root function. So what's going on here is that a, h, and k are going to move this graph that you see right here. We're going to move that around. All right, well, here is how we get that moved around. All right, let's start with h. Okay, h gives us a horizontal transformation. I'm just going to write horizontal. Okay, so h moves us horizontally. If under that radical sign, okay, if under that radical sign it's minus h, okay, if it's x minus h, well, then we're going to go right h units. Okay, that's what the h does when it's x minus h. When it's x plus h under that radical sign, you can probably guess it, we're going to go left h units. Okay, so h moves us horizontally, so we're going to move either right or left. Next, k. K is going to move us vertically. Okay, it's going to be a vertical transformation. All right, so this time, all right, k is not under the radical sign. K is outside the radical sign. Okay, so when we have a plus, let me make that a little bit smaller so we can include the whole thing. When it is plus k, we move up. Okay, and we move up k units. When it's minus k, we move down. Okay, so H and K take care of the left and right movement and the up and down movement. Okay, A, okay, does a few different things. Okay, A deals with the orientation and shape. Okay, A deals with the orientation and shape. Okay, so if A is less than 0, the graph is reflected across the x-axis. Okay, so what that means then in terms of what the picture is going to look like, it's going to curve differently. Instead of what you see here, because what you see here in this graph right here, all right, that's when A is greater than 0, right? When A is less than 0, it's going to curve like this, okay? So your curve will look like that when A is less than 0. Okay, that's one of the things that A will do. Okay. Now, A also does a couple things. Okay, it's going to stretch. Okay, so if the absolute value of A is greater than 1, we stretch vertically. Okay, we stretch vertically. When the absolute value of A is between 0 and 1, we stretch horizontally. Okay, we stretch horizontally. All right, so that takes care of the orientation and shape. Now, A also plays a role, okay, in our range. All right, so pay attention to this, because you're going to be asked to find the domain and the range of these radical functions. Today, just the square root functions. So here's how it plays a role in the range. Okay, all right, when A is greater than 0, your range is f of x is greater than or equal to k. All right, now compare that with this. When A is less than 0, your range is f of x is less than or equal to k. So the sign changes. Okay, the inequality sign changes. Okay, so we're going to use A to help us determine, all right, what the range is. Now, A has nothing to do with the numerical value that's going to be involved in the range. It simply has everything to do with which inequality symbol to use. All right, well, let's come down here and let's work with it. All right, so graph each function and state the domain and the range. Okay, we're going to state the domain and the range right off the bat. Okay, right off the bat here. All right, so f of x equals x plus 4. Now, what you're missing here that you don't see is A and K. All right, this is H. All right, now plus 0, so K is 0, and then A is the coefficient of the radical sign, and when you don't see one, it's 1. 1 times that radical sign. Okay, so first of all, the range. Okay, well, A is greater than 0. All right, so that means that our range, we're going to use this inequality sign. All right, and our range is going to be f of x is greater than or equal to whatever our k value is. Okay, where our k value is 0. Okay, now to figure out our domain. Okay, to figure out our domain, underneath the radical sign, that value, okay, after you plug in whatever you plug in for x, that value has to be greater than or equal to 0 because the square root of negative numbers, those are imaginary. We can't graph them. So to find the domain, you take what's ever under the radical sign. In this case, it's x plus 4. And you always set it greater than or equal to 0. Because what you're saying there is whatever's under the radical sign has to be positive or 0. It can't be negative. All right, and what we're going to do, we're simply going to solve that inequality. So x is greater than or equal to negative 4. That's our domain for this one. X is greater than or equal to negative 4. Okay? All right, so when we come over here to our f of x table, the first value we're going to use is always going to be that value involved in the domain because that's going to be either the smallest or largest value we can use. Okay, so negative 4. Okay, and now what that's telling us to fill in, as far as filling in the rest of the chart, all right, our domain's telling us that the other x values we pick have to be greater than or equal to negative 4. Okay, so I'm going to pick the following, and then I'll tell you why. Negative 3, 0, and 5. Now, why I picked those particular x values is because when I plug those in to my function right here, okay, when I, for example, go the square root, okay, of negative 4 plus 4, all right, I get the square root of 0, which is a perfect square, which is 0. Okay, and then I plug in negative 3. The square root of negative 3 plus 4 is the square root of 1, which is a perfect square, which is 1. Okay, and the same thing happens when I plug in 0. I get the square root of 4, which gives me 2. And when I plug in 5, okay, the square root of 5 plus 4 is equal to the square root of 9, which is 3. So the first term, or I'm sorry, the first value you pick, all right, for your xy table in the x column, okay, this value right here, all right, is determined from that value right there. Okay, and then from there, it just depends on what your inequality sign is here. All right, I'm picking numbers bigger than negative 4. And I'm going to pick numbers that create a perfect square so that my numbers are nice. All right, so now we're going to graph this on our graph. Okay, so negative 4, 0. Negative 3, 1. 0, 2. 5, 3. And we make our curve. Okay, and there is our first square root function that we have graphed. Okay, let's move over here to number 2. Okay, all right, so number 2. Okay, number 2, range. Okay, my a value is 1. Okay, my a value is 1. Remember, there is a 1 right here. Okay, h is there, and k is now here. All right, so my range, a is greater than or equal to 1. I'm sorry, a is positive, so f of x is going to be greater than or equal to. And then it's always the k value that follows, so f of x is greater than or equal to 2. All right, for my domain, I take what's under the radical sign, and I set it greater than or equal to 0. Solve for x. X is greater than or equal to negative 6. That's my domain. Okay, so that negative 6 is where I start my xy table. Again, I'm going to be greater than or equal to this number, so I'm going to build with numbers bigger than negative 6. I'm going to pick the following because when I plug these in, okay, because when I plug these in, they create a perfect square. Okay, when I plug in negative 6, I'm going to get 2. When I plug in negative 5, I get 3. When I plug in negative 2, I get 4. And when I plug in 3, I get 5. Plot them. 6, 2. Negative 5, 3. Negative 2, 4. 3, 5. Arrow on one end, dot on the other. All right, turn the page. Okay, now up here at the top, number 3. Okay, number 3. All right, square root of x minus 2 plus 5. Okay, again, my a value is 1. My a value is greater than 0. It's positive. So my range is f of x is greater than or equal to. Okay, and we go ahead and we pick the k value always. So it's greater than or equal to 5. Okay, now my domain, I take what's under the radical sign, x minus 2, set it greater than or equal to 0, solve for x. So x is greater than or equal to 2. Okay, 2 is the value I'm going to start with in my xy table. I'm going to, again, pick values greater than 2, because that's what it's telling me to do in my domain. So I'm going to pick 3 and 6, because those are numbers that will create perfect squares. Plug in 2, you get 5. Plug in 3, you get 6. Plug in 6, you get 7. Plot them. 2, 5. 3, 6. 6, 7. There it is. All right, so far, all of our a values have been greater than 1 until now. Okay? All right, so in our next problem, number 4, okay, this time our a value is negative 2, so it's less than 0. All right, our h value is here, and then again, our k value is going to be 0. Okay, so this time, since a is less than 0, or it's negative, the sign on our range is going to change. F of x is going to be less than or equal to our k value. So f of x is going to be less than or equal to 0. We still find the domain the same way. So I take what's under the radical sign, set it greater than or equal to 0, and solve for x. So x is greater than or equal to negative 3. That's my domain. That's what I'm going to start with. Okay. Now, I still want to choose numbers greater than negative 3. All right, so I'm going to choose negative 2, 1, and 6, because those will create perfect squares, and those will give me the answers of 0, negative 2, negative 4, and negative 6. Okay, so I'm going to go ahead and plot them. Negative 3, 0, negative 2, negative 2, 1, negative 4, 6, negative 6. Now, when a is less than 0, okay, well, what we said earlier, all right, when a is less than 0, and if you go back to the front page, we said, okay, it's going to curve like you see here when a is greater than 0, but then it's going to curve this way when a is less than 0. Okay, so we come here, and the dots kind of dictate that for us, okay? But this time our graph is going to look like that. And that's number 4. All right, so now we're going to transition from square root equations to square root inequalities. All right, and with the square root inequalities, there's just a couple things you have to be made aware of, just like when we were doing linear inequalities, right? So some of the similarities between square root inequalities and linear inequalities is that there's going to be shading, and the line you draw, the boundary line, is going to be either dotted or solid, and the rules are the same, okay? If, all right, you have either one of the two less than symbols, all right, you're going to shade below. That's the same. If you have one of the two greater than symbols, you're going to shade above. Okay? So again, right, those two rules haven't changed. This also hasn't changed. Dashed line with those two symbols. Solid line with those two symbols. Okay, now, here's one thing that's a little bit different. All right, because, and I'm going to scroll back up here to the equations. All right, you have, for every square root function, all right, you have this point like right there. Okay, you have this initial point right there. Now, that point, when we're talking about inequalities, can either be open or closed. Okay, here's the rule that you follow for that. Okay, if you have a less than sign or a greater than symbol, all right, that goes with the dotted line, then your dot's going to be open. All right, and likewise, if you have the less than or equal to or greater than or equal to, all right, and you have a solid line, you're going to have a solid dot. That's the only thing that's really all that different. Okay, how we find the domain and the range doesn't change, okay, if you were asked that. Okay, we do need to establish what the domain is to get our first x values. So x minus 4 greater than or equal to 0. X is greater than or equal to 4. Okay, so 4 is the first value I choose. Okay, then I build from there. Okay, I'm going to pick 4, 5, and 8. When I plug those in, I get -6, -5, and -4. Okay, well, two things here let's talk about before we graph this. Okay, I have a less than symbol. Okay, that means I'm going to shade below, and I'm going to have a dotted line. Okay, I'm also going to have an open dot. Okay, that open dot occurs at the initial point, and that initial point is 4, -6. Okay, so 4, -6. Okay, 5, -5, 8, -4. Okay, dotted line, dashed line, whatever you want to call it. Okay, and now the shading. Okay, I'm going to shade below. Now, all right, this dot right here, okay, that dot right there tells you the leftmost boundary. Okay, so if I were to draw a line, vertical line, all right, right there, all right, none of my shading can go to the left of that. Okay, so when I shade, there's like this vertical, there's like this boundary right there where that open dot is. Okay, now I'm going to erase that because it's not actually part of my graph. All right, but my shading goes just right there. All right, come over here. Number 6. Okay, let's establish that first x value. 2x plus 1 is greater than 0. So x is going to be, I'm sorry, greater than or equal to. Okay, x is going to be greater than or equal to -1/2. Okay, so that's the first number I choose, -1/2. My other numbers have to be bigger. I'm going to choose these two because that will give me perfect squares. When I plug those in, I get 0, 1, and 3. Okay, now a couple things before we start. I have a greater than or equal to, so I'm going to shade above. Okay, I'm going to shade above, and on this time I'm going to have a solid line. Okay, and a solid closed dot. Okay, so -1/2, 0, solid closed dot, 0, 1, 1, 2, 3, 4, 1, 2, 3, 4, 3, solid line. Okay, now we're going to shade above, and I really should make this go through the whole graph here. Okay, I'm going to shade above, so again, I have like this vertical boundary line here, and I'm shading above. All right, and I'm going to erase that because it's really not part of my graph. That's number 6. All righty, 2 more. Okay, number 7. Okay. Establish your starting point. We're going to start at -2. I'm going to pick -1. Oops. Okay, I'm going to pick -1. And I'm going to pick 2. Okay, when I plug those values in, I get -4, -5, and -6. Okay, -5. Now, look at your A value. Your A value is less than 0. It's negative. So that means that our graph's going to have this type of shape. Okay, I have a greater than symbol, so we're going to shade above. We're going to have a dotted line. And we're going to have an open dot. Open dot at -2, -4, -1/5, and then 2, -6, dotted line, dashed line, and we're going to shade above. So again, it's like a boundary right there. Shade above. Last one. Okay, establish your starting point. X is greater than or equal to 0. Nothing to solve for. We're starting with 0. And then everything's going to be bigger than that. I'm going to choose 1 and 4. When we plug those in, I get 4, 5, and 6. A couple things. Since I have a greater than or equal to, I'm going to shade above. I'm going to have a solid line and a closed dot. So at 0, 4, I'm going to have a closed dot. 1, 5, 4, 6. Solid line. Shade above.